Hello everyone, my name is Bharat Vyas and I work as a Spectrum Protect Level 2 Support Engineer. Spectrum Protect was formerly known as Tivoli Storage Manager, also referred as TSM. Today I would like to present Spectrum Protect Database Backup and Restore functioning and why it is important operation of Spectrum Protect server. So let's start with our presentation. In slide number 2, we have an agenda. So first, I will give you an introduction on Spectrum Protect database and logs, and second I will provide detail about type of DB backup and restore. There I will also talk about command syntax used by both operations. Then third, I will cover how to configure Spectrum Protect server to take the database backup, and then I will give you a brief when we may require to run the database restore and what are the recommendations prior running the restore. And the last, troubleshooting, I will talk about what are the common causes of database backup failure and how do we resolve it. So moving to slide number 3, here is the diagram represent the Spectrum Protect architecture. There are main two components of Spectrum Protect, client and server. On the left, you can see clients that need to back up their data into Spectrum Protect or TSM server. Client consists of application clients like DB2, Oracle, Exchange, virtual machine, and file system level backup. In middle, you can see Spectrum Protect server that mainly consists of database that store the metadata information of clients, backed up data along with the other server detail. So Spectrum Protect on TS or TSM server use DB2 database. Before 6.x, we used to have TSM proprietary database where maximum database size was 500 gigabyte. But after we have introduced the DB2 as our database, then we are keep increasing the supported DB size that help to store large amount of data in TSM server. At extreme right, we can see Spectrum Protect or TSM server connected to storage device where the actual client data get stored. A storage can include random access device or sequential access device. We also have cloud storage like AWS, IBM Cloud Storage. Now moving to slide number 4, when we install the Spectrum Protect or TSM server, a database also gets installed with TSM, and we have DB2 as database. A database stores following informations: client node and administrator detail, like how many clients are authorized to run backup into TSM server. Client policy and schedule information, like how many days a file stored into Spectrum Protect server and which storage it will go. Third, location of the client data on storage device. What are the devices attached to Spectrum Protect server? And the last one is server settings. Here you can see a table that shows how DB size increasing with every version of Spectrum Protect server. Earlier, with version 5.5, we used to have maximum database size around 500 gigabyte. But after we have added DB2 as TSM server database, we have tested around 6 terabyte of database size. And every year with the new version, we are increasing the size. The database is heart of Spectrum Protect server, because if we lose the database, then we cannot recover the data. Hence, it is very important to save your database. Now I'm moving to slide number 5, Spectrum Protect recovery log. Like every database, Spectrum Protect too has logs, so recovery logs. Recovery log is nothing but a scratch pad where initial transaction gets written, and once the transaction committed to database, then the logs gets cleaned up. Hence, the recovery log help to ensure that failure does not leave the database in inconsistent state. So there are 4 types of recovery logs: active log, archive log, active mirror log, and active failover log. So when you install the Spectrum Protect server, that time you need to specify the path of all 4 logs. Both mirror and archive logs are optional. So if you do not specify the active mirror and failover log, then it won't define to the TSM server. However, you can define them at any time by adding an entry into your dsmserve.opt file. Let me tell you the functioning of each logs. Active log has the in-flight transactions, and once transaction completes, it moves to the archive log. A transaction means any operation running on TSM server like backup, restore, or any server operation. Archive log contains the copies of closed log file. Archive log is needed during the recovery of database. Third one is active mirror log. It's nothing but making a copy of your active logs. In case there is an issue in writing the transaction in active log, then it will be written into mirror logs. If you are specifying the mirror logs, then you need to consider the performance since logs are written at 2 places. So that makes some delay. Last one is archive failover log. It is an optional log but recommended, since if your archive logs gets filled up, then it will write into failover log. Now let me also explain you how the logs flow. So once any transaction start like backup, then it writes into active logs, and once the active logs file is full, it copied into the archive log. In case if archive logs directory has some issue, then it will be copied into archive failover directory. Unfortunately, if the archive failover directory also have some issue, then movement from active to archive log will fail, and that will cause active log to fill up and crash the Spectrum Protect server. So if active log is successfully copied into archive log, then the active log is a candidate for deletion, or ideally it is renamed. One more important point I would like to cover here is that you must have all the database and logs on separate file system or physical disk to have better performance. Now moving to slide 6. So for any disaster recovery, we must have database backup. Spectrum Protect, we have 3 types of database backup: full backup, incremental backup, and snapshot backup. Full backup will back up complete database, and then it will clean the archive logs. Incremental backup will only back up the change database since the last backup. And the third one is snapshot backup. It is same as full backup, but it won't affect your full plus incremental backup series. And it's mainly used for disaster recovery sites. Here I have also included the DB backup command syntax. So in the type parameter, you need to specify what kind of backup you want: full, incremental, or snapshot backup. The device class used for DB backup need to be sequential. So we need to specify the device class as well in the backup command. So that must be a sequential device class. Since Spectrum Protect use the DB2 as database, so it is also possible to run the DB backup from DB2 end. It is not recommended to just run the TSM DB backup from DB2 end. However, there are some conditions when we require to run offline DB backup from DB2 end. Like when your archive logs directory gets full and TSM server unable to start. So to clean up the archive log, you must run the DB backup from DB to end. Second condition would be like, in any case, your TSM DB backup is not working from some reason, then you can go ahead and run the DB backup from DB to end to clean up the archive logs. Now I'm moving to next slide 7. Spectrum Protect can recover by two ways. One is most current state and second is point in time recovery. Let me explain both the restore procedure by an example. Let's say if you taken your Spectrum Protect server database backup today at 10 a.m. and at 2 p.m. your server get crashed due to some reason. So if you run the most current restore or roll forward recovery, then server will restore the 10 a.m. database and then it will apply the logs between 10 a.m. to 2 p.m. So in this case, you do not lose any data. However, in case server crash due to log or DB corruption, then you have to choose the point in time database restore option. So in this case, it will just restore the 10 a.m. database. So in this case, you will lose the data between 10 a.m. to 2 p.m. Here is the command syntax of DB restore I have mentioned here. So for point in time DB restore, you need to specify the to date parameter, or you can also specify to time parameter. For most current restore, you need to just run the DSM serve restore DB command without specifying those two parameters, to date and to time. As I discussed in previous slide, we can run the DB backup from DB to end. So similar way, we can restore the same database from DB to end if it is required. So here I have mentioned the command that we can use to restore the database from DB to end. Now I'm moving to slide number 8. So along with Spectrum Protect backup, the 3 files, volume history file, device configuration file, and dsmsaw.opt are important files that needed to recover your Spectrum Protect server without any issue. So make sure you make a copy or backup all of these 3 files. There are few points that you need to consider before you run the DB backup. As I mentioned here, what is your DB size? Since DB backup time depends upon your database size. Where is your DB and logs directories are reside? If they are on slow disk, you might see performance issue during the database backup. And third point is how frequently you need to take the database backup. So ideally, it is recommended to run the database backup every day. Now moving to slide number 9. Here I have provided some steps that need to be checked or configured prior to running a database backup. If you miss any of these steps, then DB backup may fail. So here I have included the example for Unix platform. Here my instance name is tsminst1 and the path of my instance is /home tsminst1 tsminst1. So step 1 says you need to be logged in as an instance user. So you can confirm by running the whoami command. Then you need to open the instance profile file and make sure you have those entry db2 profile path entry as I have given in this example here. If not, you need to specify the complete path of the db2 profile. In step 3, it's very important step. You need to make sure dsmi underscore dir, dsmi underscore config, and dsmi underscore log path has been set correctly. dsmi underscore config parameter must point to your tsm dbmgr.opt file. It's option file. dsmi underscore dir parameter must point to the dbb k-API directory. For version 6, it must point to your API bin directory, not the dbb API directory. Last but not the least, dsmi underscore log that point to your directory where you want to generate your log file. Once you set those parameters, you need to restart the profile to take an impact of those updated values. So for that, you need to run .profile command, or either you can log out and log in from the instance user. In step 5, you need to create the option file name as tsmdbmgr.opt that must have server name entry as per given in the example tsmdbmgr underscore instance name. You need to specify the instance name in the server name parameter. Now I am moving to slide number 10 that shows the step number 6. You need to create the dsm.sys file or update it. Make sure you create the dsm.sys file in correct directory as pointed by the dsmi_dir. In step 7, you need to stop and start db2. So whatever changes we have done in previous steps will be applied at the db2 as well as OS side. Here step 8 only required for version 6 because we have to set the password in version TSM server version 6. Now I am moving to slide number 11. Here the example of Windows. So I won't go through each steps here since there is only difference of file name and their path. So I am moving to next slide number 12. So in previous slide we have done the configuration outside of Spectrum Protect server. Now you need to set up the device class at server end before running the database backup. So here we have the command set db recovery and the device class name. This command set the default device class for Spectrum Protect DB backup. If you do not set the device class for DB backup, then DB backup will fail. So now moving to slide number 13. So here are some situations when we may require to run the database restore. So first condition is when Spectrum Protect server DB or log file has been corrupted. So in this case, TSM won't start. So you need to run the DB restore to up the TSM server. Second condition says when the active log file is missing. So that will cause TSM server to crash and you are not able to start the server. So in this case, either you have to search, you need to either search the whole system to find out the missing file and place into the active log directory. But if you do not find the file, then you have to run the DB restore. Third condition says database related file is missing or corrupted. Then to require the DB restore. Fourth and fifth, in case you are upgrading or migrating your Spectrum Protect server from version 6 to version 7 and that fails, you want to revert, then you need to restore your version 6 database. Last but not the least, in case you have added a new DB directory, but Spectrum Protect is not distributing all data in newly added directory, then a DB restore will help to rebalance the data across the DB directories. Now I am moving to slide number 14. If you come across a situation where you need to run the Spectrum Protect DB restore, then those following points you need to consider prior running the database restore. First, the server version should be the same. Like if you have a DB backup from version 7, then you need to make sure during restore TSM server should be same level. You cannot restore version 7 database into version 8 server. Second, for version 6, we use the client API for backup. So make sure client API version should be same or higher as the version used for DB backup. Like during DB backup, if TSM client version was 6.3.5, then you must have same or higher version client during version 6 restore. This condition won't apply for version 7 and version 8 since both these new versions have their own copy of API. Third point, if you are restoring database on same server, then make sure DB and log directory structure must match. However, if you want to use different database directory, then you have to specify on parameter in DB restore command. Fourth point I have mentioned here is that you must have DB log directory empty prior running the point-in-time database restore. There are three ways we can empty our database or log directories. Either you manually delete the log files or you run the tsm serve remove db command. Ideally, both way you can delete the logs or db directories. In case if both are not working, then you can use dbt drop db command to clean up the db and log directories. Fifth one is directory size. So let me explain last point with an example. Like you want to restore a DB into DR server, and if your production server database size is 100 GB, then must make sure the DB size at the DR server should be greater than 100 GB. Now I am moving to slide number 15. Here I will discuss about what are the steps we need to perform once we successfully completed the point-in-time database restore. The reason behind running those steps to sync the data between server database references and the actual data stored in the storage devices. Since there is a possibility of data mismatch after the point-in-time DB restore. The reference link is given in the slide on the top. So in this chart, first block say you must first take the backup of 3 config file, volume history file, device configuration file, and tsmserver.opt file. Then stop the tsm server and add 3 parameters in tsmserver.opt file as shown in third block. No migration reclamation, expire interval, and disable schedule is yes. Once you add those entries, start Spectrum Protect server or TSM server. Now open your volume history file and identify 3 types of volume which status shows stg reuse, stg new, or stg delete since the original backup, and run the audit volume with fixed equal to yes against those volume. If audit detect any damaged file, then you can restore those files from the copy pool volume by using restore volume command. But you don't have copy pool, then you will lose your data. If there is no damage, then go to the next steps as mentioned in slide number 16. The reference link is given in this slide on the top. For specific configuration, there are some special steps to be taken which are given in this reference link. If there is no damage, then we'll check if you have container pool. If you have the container pool, then you can go ahead and check the 0.6b for reference document. Also check, do you have the node replication configuration? If you have it, then check the 0.6c. Third is you need to check whether you have the dedupe pool or not. If you have, then you can refer the 0.6d. If you don't have any of those configuration, then just remove the entries from dsmserver.opt file that we have added in step 2 and restart your DSM server. That's it. So now moving to slide number 17, troubleshooting. Here I will talk about common return code received if the database backup fails and what need to check to resolve it. If you receive return code 106, then it indicates the log file pointed by DSM I underscore log parameter does not have proper permission. So you can resolve it by either you need to check the permission or the owner of the file. So it must make sure the owner should be TSM inst1 or the instance name. If you receive return code 137, then it points to the authentication issue. It means you have not specified the TSM DBMGR as API password. So to resolve it, you must use the correct password using the DSM API PW command. Let's say if you receive the return code 400, so that indicates you have the bad option in your OPT file. So OPT file is dsm.sys or tsmdbmgr.opt. So identify those incorrect option and remove it. So in case if you receive return code 406, so that indicates that either dsmi underscore config points to incorrect option file or that file do not have the proper permission. So make sure check the dsmi underscore config point to the correct OPT file as well as have the correct permission. So those are the common codes that we receive during DB backup if it fails. Now moving to the next slide 18. Here is another way to diagnose the DB backup and restore issue. db2diet.log is the file where you can see complete activity of your database backup and restore operation. There are 4 kind of messages you can find in db2diet.log: catastrophic, severe, error, and warning. So if DB backup or restore fails, then it comes under error section. So I am just moving to the next slide 19. Here I have shown the example of DB and restore messages that occur in db2diet.log. So you can check when the backup started, when it completes, when the restore started, and when it completes. And if you see any failure, you will receive the error code in these messages. So this is just example of database and restore messages. Now moving to the next slide 20. Here I have included some reference link. So that will help to know more about your database and recovery logs, as well as the database backup and restore configuration. So now we are ready to have question and answer session.